What's up, everybody? Got a video here for applied calculus. This is partial derivatives. So let's go ahead and get started. So it says if z equals f of xy and y is held constant, z becomes a function of x alone. The derivative of this function with respect to x is termed the partial derivative of z with respect to x. And similar, if x is held constant, the derivative of the function with respect to y is the partial derivative of z with respect to y. All right, so basically what we've got here, if you've got a function z equals something in terms of x and y, or it may be labeled f of xy equals something in terms of x and y. If you take the partial derivative with respect to x, you do everything just like you've been doing, just like you normally take a derivative. The only thing is you treat y like it's a constant. And then if you take the partial derivative with respect to y, you do the same thing, that just how you've been doing derivatives through the whole course. The only thing is you treat x like a constant. Okay? So let's look at the notation. So it says for the function z equals f of xy, the notations used for the partial derivative of z with respect to x are the partial of z with respect to x. Now, this is not a 2. It's a partial derivative symbol. That's the best I can draw it. You can Google partial derivatives and you'll see it, and it'll show you what the symbol actually looks like, but it's something close to this. And then we've got the partial of f with respect to x, and then this right here also means the partial of f with respect to x, and then the partial of f of xy with respect to x, and then the partial of f with respect to x, these little subscripts. If that was a y, then it would be the partial with respect to y. All right, so, and we'll get into second partial derivatives also in the video. We'll do that at the end. All right, so let's look at the example. It says find the partial derivative of z with respect to x and the partial of z with respect to y. All right, so let's do this one. So we've got the partial of z with respect to x is equal to, so remember what I said, treat y like a number. So the derivative of 4x squared is 8x plus the derivative of xy is what? Y. So let's look at that a little bit more. You might be confused. All right, so look at this. What is the derivative of 5x? It's 5. What's the derivative of negative 3x? It's negative 3. Well, what's the derivative of y times x? It's y. Y is treated just like a constant, like this 5 and this negative 3. You just got to look at y as being a number. And what's the derivative of a number times x? It's that number. Okay? And then the derivative of y squared, remember, this right here is a number. So the derivative of that is 0. The derivative of a constant is 0. And so this is your answer. All right? Now let's look at the partial of z with respect to y. All right, so what's the derivative of 4x squared? Remember, we're doing it with respect to y, so that means x is treated like a number. So the derivative of 4x squared, well, that's just a number. That's 0. And then we have the derivative of xy. Now remember, x is a number. What's the derivative of a number times the variable? Well, it's just x. And then the derivative of y squared, so that is minus 2y. And there's your answer. All right. Don't worry, we're going to work some more examples. All right, let's look at this one. So let's take the partial of z with respect to x. All right, so on this one, we have to do what? We have to do the quotient rule. Now, I want you to look at this x times natural log y. That's the numerator, right? Okay, we're not starting to work the problem yet. I just want to show you something. This right here, when you're taking this derivative, it's like you're taking that derivative. This natural log of y is like that 5. Okay? All right, so let's do the quotient rule. So the derivative of the numerator, which would be what? Natural log y. That's the derivative of natural log y times x. Natural log y is a number. We consider it a number. Times the denominator. All right. Minus the derivative of the denominator times the numerator, x natural log y, all over the denominator squared. All right. And now we just have to clean this up some. So this is going to be, now look what I can do here. I can take this natural log y. See how that's a common factor to both of them? I can factor that out. So that's natural log y times, so I pulled that out. So I'm left with x squared plus 1 minus, and then this right here is 2x squared, all over x squared plus 1 squared. And so that's going to give me natural log y times, and that's going to be 1 minus x squared over x squared plus 1 squared. And so there is your derivative. All right. Now let's take the partial of z with respect to y. All right. So this might look complicated, but it's not. Let's think of it like this. What would be the derivative of 5 times the natural log of, say, x? This is not anything working the problem. We're just going off on the side here. What would the derivative of that be if we were taking the derivative with respect to x? That would be 5 times 1 over x, right? Because this 5 here, that's just a constant, and so the derivative of natural log x would be 1 over x. Well, look at this one. Couldn't we write this as x over x squared plus 1 times the natural log of y? You see this right here is like this 5 here. That's a constant. We're taking the partial derivative with respect to y. So all the x terms, we consider those constants. And so this would be x over x squared plus 1 times, and then what's the derivative of natural log y? It's 1 over y. And so this would be x over y times x squared plus 1. And there's your derivative. All right? You've just got to get it in your mind that when you're taking the partial with respect to x, you've got to get in your mind that y is treated like a number. And when you're taking the partial with respect to y, you got to get in your mind that x is treated like a number. That's what you've got to do. Okay? All right, so let's look at this one. So for the function f of xy equals x squared times y times square root of 2 plus xy squared, find fy of 2, 1. So we want to find the partial of f with respect to y, and we want to evaluate it at the point 2, 1. So we have fy. Well, first, let's not do it like that. Let's find the partial with respect to y first, and then we'll evaluate it. So you can see we've got two functions here. See that multiplied together? Remember, x squared and this x, those are treated like numbers. Okay? So we have to do the product rule here. And so we have the derivative of the first term. So the derivative of x squared y is just x squared. And then that is times the second term. All right? So this right here is the derivative of the first term, and then times the second, plus the derivative of the second. So now we're taking the derivative of this right here. Now, if you've watched these videos, I'm sure you have seen this before. If not, I'll explain it real quick. If you need more information on it, just go search my channel for a shortcut for finding the derivative of a square root. All right, so remember, in order to take the derivative of a square root, the shortcut here, you take 2 times whatever the square root is. That goes in the denominator. And then what goes in the numerator? The derivative of what's underneath the square root. So the derivative of 2 is 0. The derivative of xy squared is 2xy. See, the 2 comes down. 2 times x is 2x. Subtract 1 from the exponent. That's y to the first. That's what we're doing. Okay? And then that's times the first function. And so, let's see. I can clean this up a little bit. So I've got x squared times the square root of 2 plus xy squared, plus, and then that is going to be 2x cubed y squared. I'm sorry. How about we do this? Let's cancel those 2's out. X cubed y squared over 2 plus xy squared. So this 2 and this 2 cancel out. All right, and so now we have the partial with respect to y evaluated at 2, 1. That's going to be 2 squared times the square root of 2 plus 2 times 1 squared, plus that's going to be 2 cubed times 1 squared over the square root of 2 plus 2 times 1 squared. And I don't think I made a stupid mistake anywhere, but that answer should be 12. And let's see, that's 4 times 4, that's 16. Let's just make sure I did it. Oh, wait a minute. No, that's 2 times 4. Yeah, because square root of 4 is 2 times 4, that's 8. And that's going to be 8. And that's 2. So that would be 4. 8 plus 4 is 12. Okay, just making sure. Whenever I make a careless mistake, I hear it in the comments. So just making sure I didn't have any. All right, so how about this problem? All right, so find the slope of a tangent line to the surface 2z equals x squared plus 2y squared and parallel to the xz plane at the point 2, 1, 3. Also, find the slope of a line tangent to this surface, and that should be and parallel to the yz plane at the same point. This should be the word and right here. All right, so, just real quick, let me do this graph, and don't worry about it if you don't understand how I graph this, but it's gonna look, and I'm telling you right now, I'm horrible at drawing these things. It's gonna look maybe something like this. I don't know it. It's going to go back like this, and it'll come back around, something like that, and this will go across like that, and basically what we have here, you have your x, y, and your z axis. Now, This part right here, this is your XZ plane if you were standing over there, and this is your YZ plane. So we're looking for tangent lines that are parallel to this plane and parallel to this plane at this point. So we've got 2z equals x squared plus 2y squared. And we want to find the line tangent to the, let's see, what does it say? Find the slope of a line tangent to this surface and parallel to the xz plane. So what we'll have to do here is we'll have to take the partial derivative of this, okay, with respect to x. So remember, y is treated like a constant. And so this is 2, and then we're taking the partial of z with respect to x. So that's going to be 2x. This is 0. This is all a constant, 2y squared. Y is a constant. And so this tells us that we get the partial of z with respect to x is equal to x. See, the 2's cancel there. And so now I'm going to take the partial of z with respect to x, and I'm going to evaluate that at the point 2, 1, 3 at this point right here. So I only have an x term, so I'll plug the 2 in, and that's just going to equal 2. So this is that's the tangent. That's the line tangent to the curve that's parallel to the xz plane. Well, now we need to find the slope, also find the slope of a line tangent to the surface and parallel to the YZ plane at the same point. And so I've got 2z equals x squared plus 2y squared. And so I need to take the derivative of that. All right, so that's going to be 2 times the partial of z with respect to y. So the derivative of x squared, that's 0. That's a constant. And then this is going to be 4y, which this gives us the partial of z with respect to y is equal to 2y. And then we're going to evaluate this at the same point, 2, 1, 3. But notice I only have a y term, so I'm going to take the y value. This is your x, this is your y, and this is your z coordinate. So y is 1, so this is 2 times 1, which equals 2. And there's your answer. All right, so that's finding the slope that's parallel, that's tangent to a curve and parallel to a certain plane. All right. All right, so how about this one? Let's see, it says an electric circuit in a television transmitter has parallel resistances little r and big R. The current through little r can be found from little I equals big I times big R over little r plus big R, where big I is the total current for the two branches. Assuming I is constant at 85.4 milliamps, okay, so I is constant, we'll replace the I with this 85.4. Find the partial of little I with respect to little r and evaluate it for big R equals 0.15 ohms and little r equals 0.032 ohms. All right, so let's take the partial of I with respect to little r. Oh, I'm sorry. Let's do this first. Let's write the problem down. So that's I is equal, and replace this big I with 85.4. And so that's little r plus big R. All right, now let's do it. So I got the partial of I with respect to little r. All right, so taking this derivative, looking at it now, let's make things easy on ourselves. First thing that might pop into your head, hey, let's do the quotient rule. And look, if you do the quotient rule, that's fine. Nothing wrong with it. But what I would do to make it easier is write it like this. Everything in here is a constant except this little r. That's a number. And so let's do the derivative. That's going to be negative 85.4 times big R times r, little r plus big R raised to the negative 2. And we're doing chain rule, so times the derivative of little r, which is 1. And so I get the partial of I with respect to r is equal to negative 85.4 r over r plus big R squared. And so that's your derivative right there. And so now let's evaluate this, the partial of I with respect to r. We're going to evaluate that where little r is equal to 0.032 and big R is equal to 0.15. And so that's, let's not forget that negative. That's 85.4 times 0.15 over, that's going to be 0.032 plus 0.15 and all that squared. And after you punch that into your calculator, you get negative 387 milliamps per ohm. And there's your answer. I'm assuming that's right. I didn't punch it into my calculator. I got the answer, so that might be rounded. I'm not sure. Okay. All right, so let's look at this. We've got second order partial derivatives of a function. So this is the second partial. So this is the second partial of f with respect to x, the second partial of f with respect to y. This is the second partial with respect to x and then y. And then this is the second partial of f with respect to y and then x. All right, so it's really easy. All you're doing is following along what the bottom has, what the down here, what that has. That's what you're following along with. So let's take a look at some examples. All right, so we're finding the second order partial derivatives of this function here. So basically, I mean, they didn't tell us exactly what to find. They just, basically they're saying find all of these. All right. So the way I like to do this, I just like to start out doing the partial of z with respect to x. So that's going to be what? 3x squared y squared, right? The 3 comes down, subtract 1 from the exponent. Y is a constant. Minus 3y cubed. So that's the partial with respect to x. Then I'll find the partial of z with respect to y. So that's going to be 2x cubed y, right? The 2 comes down, subtract 1 from the exponent, x is constant, and then minus, and that's going to be 9xy squared. All right? So I found the first partial with respect to x and with respect to y. All right. Now, let's find this one, and then let's find this one, and then we'll do this one and this one. Okay? All right, so the second partial of z with respect to x. So all that means is you find the partial of this with respect to x, and then find the partial of this with respect to x. And so that's going to be 6x y squared, and this is 0 because y is a constant. So there's one answer. Now let's find the second partial of z with respect to y. So I found the partial of this with respect to y, and now I'm going to find the partial of this with respect to y. And so that's just 2x cubed minus, and then the 2 comes down, that's 18xy. All right. So now let's find these two. So I'm going to find the second partial of z with respect to x and then with respect to y. All right. Now, just follow what it says. That's all you're doing. I'm going to do the partial with respect to x. So I did the partial with respect to x. And now I'm going to take the partial of this with respect to y. So all you're doing, you're starting with your original function. You're going to take the partial of that with respect to x, and then the partial of that, which is this, with respect to y. All right. So now let's take the partial of this with respect to y. That is going to be 6x squared y minus 9y squared. All right. Now let's find the second partial of z with respect to y and then with respect to x. So you see here, I took the partial of this with respect to y. See that? Which I got here. Now I take the partial of this with respect to x. So that's going to be 6x squared y minus 9y squared. All right. So there you go. That's your second partials. So it's just a matter of, you know, of just, it's like you're following you're just following what they're telling you to do. And let me say this, the alternate notation that you might see for this one, you could see that written like this. You could see this one written like this. This one you could see written like this, and this one could be written like this. You know, instead of writing this, you could write this. Okay? And then, look, if they wanted to, you could go ahead and tack on another x there and do the third partial with respect to x, then y, then x. And so once you're here, now we're working on this x here, so that would just be 12xy, and this would be 0. So hopefully that makes sense. Okay? All right, so we got a note here. So if the function and partial derivatives are continuous, then the second partial of z with respect to x and then y is equal to the second partial of z with respect to y and then x. So whatever order you do it in. And notice that happened up here. All right. So, you know, I mean, we don't necessarily have to work this problem, but we might as well. Let's see, give us some more practice. And it says show that, well, it says for f of xy equals the inverse tangent of y over x squared, show that there's the second partial with respect to x and then y is equal to with respect to y and then x. All right, so let's take the partial of f with respect to x. We got to do that first, and then we'll take the partial with respect to y, and then we'll work on the second partials. All right, so what is this? Inverse tan. Inverse tan. What do we have? Well, that's 1 over 1 plus y over x squared squared, right? Times the derivative of what you're taking the inverse tangent of. Now remember, we're doing it with respect to y. And so I'm not going to go through all the steps, but you could write this as y times x to the negative 2 and do the power rule, negative 2y x to the negative 3. So that would be times negative 2y over x cubed. And, oh goodness, what would that be after we simplify it? That is going to be, well, I'll tell you what, we'll work on simplifying this one, and then the next one's going to be similar, so we won't really show a lot of work on that. But this is 1 over 1 plus y squared times x to the 4th times negative 2y over x cubed. So what I'm going to do here, I'm going to multiply by x to the 4th over x to the 4th, this first fraction here. And so that's going to give me x to the 4th over x to the 4th plus y squared times negative 2yx cubed. And so you can see how these cancel and we're left with the x here. So this is going to be negative 2xy over x to the 4th plus y squared. All right, so that's the first partial. Now let's take the partial of f with respect to y. So that's going to be, kind of the same thing. That's going to be 1 over 1 plus y over x squared times, and then we got to take the derivative of this with respect to y. Well, remember, y over x squared is the same thing as y times 1 over x squared. The 1 over x squared is a constant, so the derivative of that would just be 1 over x squared. And I'm not going to go through all the simplification there, but when you simplify it, you would get x squared over x to the 4th plus y squared. So there you go. And then what we would have to do is we would have to take the partial of this with respect to y. So I've got the second partial of f with respect to x and then with respect to y. So I need to take the partial of that with respect to y. So we're going to have to do quotient rule there. So that's negative 2x times x to the 4th plus y squared minus, and then the derivative of this is 2y times negative 2xy over x to the 4th plus y squared. And let's see, what is that going to be? That's going to be negative 2x to the 5th minus 2xy squared plus, and that's going to be 4xy squared over x to the 4th plus y squared. I hope I didn't screw something up somewhere. And so that's actually going to be 2xy squared minus 2x to the 5th over x to the 4th plus y squared. And I'll make sure, let me double check my work. We don't want comments, you did that wrong. Okay, so that's that one. And then we have to take the partial of this. So now I got the second partial of f with respect to y and then with respect to x. So I got to do the partial of that. So that is quotient rule. So the derivative of the numerator, which is 2x times the denominator, minus the derivative of the denominator, 4x cubed, times the numerator, x squared, all over x to the 4th plus y squared. And then we need to simplify this. So that's going to be 2x to the 5th plus 2xy squared minus 4x to the 5th over y to the fourth plus y squared squared. And so combine like terms, that's 2xy squared. That's going to be minus 2x to the fifth over x to the fourth plus y squared squared. And you can see we got the same thing. And I didn't make a stupid mistake working the problem. All right. So there it is. That's partial derivatives. They're not bad. You just got to practice them. You've got to be able to see it. Hey, when I'm taking the partial with respect to x, y, I have to see that as a constant. When I'm taking the partial with respect to y, I've got to look at x as being a constant. That's all it is to it. It's not bad. All right, so I hope the video helped. Check out my other videos. Give me a like, share, subscribe, and comment. And I'll see you in the next one. Later.